In this video, we will finish section 2.2. And the example that we are looking at together is called putting it all together. So all the things that we talked about, N behavior, multiplicity, X-intercept, Y-intercepts, we're going to put all these things together to graph a function. Okay. After graphing the function, we will go ahead and use the graphing calculator to see if we graphed it right. But we're going to do this without a graphing calculator first. So let's take a look. It says f of x equals negative 2 x plus 1 squared times x minus 5. So we want to describe the end behavior of graph of f first. If you want to, we don't need to, but if you want to FOIL it out, if you want to write it out in a standard form, that's okay too, but we really don't need to do that. What I can do is I can add up the multiplicities. To find the degree, okay? So in fact, let me go ahead and start with part B first, okay? And I will come back and we will do the degree and leading coefficient. So what are the zeros? First factor that I see is negative 2. But negative 2 can never be equal to 0. So that's not going to be useful. There's no x there, so that's not going to help us. What about the second factor? The second factor that we have is x plus 1. X plus 1 can be 0, right? X plus 1 equals 0 gives us x equals negative 1. Let me put that in the table. The first 0 that we found is negative 1. What about the next one? X minus 5. That can set it be equal to 0. I can say x minus 5 is 0. And that gives us x equals 5. So we found the second 0. Let's talk about their multiplicities. For the multiplicities, we are looking at their powers. X plus 1 is getting raised to the second power, right? So the multiplicity of negative 1 is 2. And because 2 is an even number, remember in class we talked about if multiplicity is even, the graph will bounce off at the x-axis. It will just touch it, but it will go right back where it came from. Okay, what about the multiplicity of x equals 5? Do you see that the factor x minus 5 does not have a power written, but that just means is x minus 5 to the first power. So the multiplicity is simply 1, and because 1 is an odd number, the graph will cross at x equals 5, okay? Now, add up the multiplicities to find the degree, okay? Let me go ahead and write that down. Hold on, what's going on with my pen? Add up the multiplicity to find the degree of this polynomial, okay? If you add 2 plus 1, you get the degree is 3. So I'm going to go ahead and write down 3 for the degree of this function. Well, look at that. This is an odd degree function. So the end behavior will be opposite. This implies that end behaviors are going to be opposite. So if one end is going up, the other end is going down. Okay, that's what's going to happen. Now let's look at the leading coefficient. Okay, if I multiply this all out, the leading coefficient will simply be negative 2. So because this leading coefficient is a negative number, what's going on with my pen? Leading coefficient is negative 2. It's the negative number. We have to, this function will be decreasing, okay? It's going to be decreasing from left to right. I can't stand this app, guys. What in the world is going on? This is slowing down on me too much. I may have to download a new note-taking app. If you guys have a suggestion, just let me know. Leading coefficient is -2. And because this is a negative number, the pattern, the general pattern will be going down from left to right. So we're looking at something like this. Okay, we're going to say because the leading coefficient is negative, this graph will rises to the left and falls to the right. And these are all based on that leading coefficient test that we talked about during our class meeting. Okay, so looking good. Now let's go find some intercepts so that we can plot them. Okay, all right, they said find the y-intercept of the graph of f. Why are they not asking for the x-intercepts? Well, guess what? Because we already found them. These are the x-intercepts. Remember we said zeros are also called x-intercepts, so the only point that I need to find is the y-intercept. To find the y-intercept, you plug in x equals 0. Okay, so what's the function? Let me zoom out and write down the function. The function is -2 times x plus 1. So I'll put 0 plus 1 squared. And x minus 5 turns into 0 minus 5. And all I need to do is just evaluate this. This is going to give me -2 times 1 squared times -5, which is -2 times 1 times -5, and that is 10. So we're going to have a y-intercept at 10. We can plot a point at 0, 10. So let me go ahead and graph this based on what we have. Remember, because we have 2 zeros, we can also plot these x-intercept. Plot -1, 0 and 5, 0, right? I wonder if I can add a page so that I can actually graph this function. Give me 1 second. I'm trying to figure out if I can add a page. Add a page. Ta-da! It did it, guys. So here's the graph. I got a couple points to plot. The points are -1, 0 and 5, 0 and 0, 10. These are my intercepts. I know the general pattern or the end behavior is falling to the right. And I also remember, basically we're putting all these ideas together. So how about I try to zoom out and do this on a bigger screen, okay? So x-axis and y-axis, draw that for me. X-axis and y-axis. Let's go ahead and do that. Okay, so we have this. And let's plot the x-intercepts first. Let me plot -1, 0, and 5, 0. Okay? -1, 0. What happened? -1, 0. Here's the first x-intercept. And 5, 0. 1, 2, 3, 4, 5. And I plot the x-intercept right there. What was the y-intercept? The y-intercept is 0, 10. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10. And I'll plot that right here. Okay. So we gave it a skeletal. What we're going to now do is fit a nice curve over here. Now I want you to remember that at -1, look, at -1, the graph will bounce. You see that? Because it had even multiplicity, it's going to bounce. I'll add that over here. Hold on. This is going to bounce right here. Okay. How about at 5? Oh dear, what's going on? So we just said this graph will bounce here, and this graph will, oh, I did not see it. I have to make sure. At 5, this is going to cross. right? At 5, this is going to cross. And the end behavior, if you remember, the end behavior is down to the right and up to the left. So we have enough information to sketch this picture. Okay, so take a look. I know to the right is gonna go down. So I'm gonna go ahead and draw a line that's going down that way, okay? But at the X-intercept, it said it's going to cross. So I'm gonna go ahead and just keep on going up. Just go to the right. And maybe, I don't know what it's going to do in the middle, but it has to go back to this point of Y-intercept, right? So it's going to touch there. And I need to come straight down so that I can go visit my X-intercept right here. But notice it says bounce. So I'm going to go bounce right off. And that matches because it's because it said to the left end behavior, this is going up. So that is my sketch of the graph. What I will now do is I will go ahead and use a graphing calculator to see if it looks similar at least. It's not going to be accurate because I only have 3 points, but the sketch should be, it should be similar, right? So now I'm going to Desmos graphing calculator and I will go ahead and graph the function. The function is -2 x plus 1 squared x minus 5. And I will do the home zoom so that you can see, maybe zoom out a little bit. Maybe I can just kind of change the, let me do that. Let me mess with the setting a little bit, okay? I'll make that to be go up to 100. I'll spread out the x-axis a little bit so that you guys can see. Okay, I just changed the setting a little bit, but isn't that matching what we just got? Oh, no, it doesn't. Oh, no, it does. Yes, it does. Yes, it does. It's just, I freaked out for a second, you guys. See, that's my graph. And this is what Desmos gave me. And if you look, we do have a Y-intercept at 0, 10. So my curve right there wasn't as high enough, but it doesn't matter. It has that pattern of, let me make this small so that you can have both graph it on the same screen. That's good. So it's going up to the left, right? It's going up to the left and it's going down to the right. It's definitely crossing the x-axis at 5, but it's bouncing off the x-axis at -1. And we have an x-intercept at 0, a y-intercept at 0, 10. That's all correct. So why do they look a little different? It's just because I didn't know how high up this graph was going to go up. So if I just want to kind of cheat off of that, I can just sketch something like that. But the pattern, it looks even worse now. But you see the pattern, right? This is continue going up to the left. So it's the same graph, really. It's the same graph. Mine is just a sketch. But I don't mind if you guys use a graphing calculator to confirm, but I want you to also be able to know how to graph these polynomial functions using x-intercept, y-intercepts, their behavior at the x-axis. But I really didn't know how far up this mountain will go up because I didn't know the relative maximum or the local maximum. You will learn about how to find these local maximum and local minimum, how high up the graph goes or how low those values go in calculus class. So hang on to, because when you get to calculus, you will be able to use something called a derivative to find those important points. But in pre-calculus class, we will only go this far. X-intercept, y-intercept, behavior at the x-axis, and the end behaviors. I'm going to go ahead and stop recording this video, and I will come back and show you more Alex topic helps, okay?